but in very simple terms, what is RBTC?
It's BTC. It's BTC running on a separated blockchain, but it's backed by Bitcoin. It's equivalent to Bitcoin. It's completely one-to-one pegged. So it's basically Bitcoin, but with smart capabilities.
Hi, and welcome to Rootstock Fundamentals, a series of conversations with some of the key contributors to Rootstock, Bitcoin's first and longest running sidechain. We've designed this series as a beginner's guide to Rootstock. We're going to start at a high level and dive right into the details. We're exploring Rootstock's origins, its cryptographic connection to Bitcoin, the security model used to protect Rootstock, and how the Rootstock network continues to evolve today. Rootstock was the first Bitcoin sidechain. It brings together the benefits of Bitcoin, security, store of value, widespread adoption, and decentralization with the benefits of Ethereum, smart contracts, programmability, token utility, and an active developer community. This combination makes Rootstock the most secure smart contract platform on the planet. And this episode, I'm joined by Jose Dalquist, Senior Engineering Director at Rootstock Labs and a very long-term contributor to Rootstock. We're going to talk about RBTC, also known as Smart Bitcoin, the native asset of Rootstock, the two-way peg, and learn all about the pegnatories and the design of the two-way peg itself. Hey, Jose, welcome to Rootstock Fundamentals.
Hey, everyone. Nice to be here. Thank you for inviting me.
Yeah, of course. We talk a lot internally about some of these topics, and I know that you are one of the key people that has been in the engine room building Rootstock for the last 10 years. So let me start with this question. When did you buy, receive, or mine Bitcoin for the first time?
Actually, I did it when I joined the company. Around 2018, I think it was. Yeah, 2018. When we were starting to talk with the people, I started to get deep into the technology. I said, okay, I'm going to get some.
Best way to find out about something is to actually try it, right? Instead of reading about it in books or in magazines.
Yeah.
Dog fooding. And you've been working on Rootstock from the very, very early days. And I think you've been working with Adrian, one of the Rootstock founders, for nearly over a decade, unless I'm wrong. So then how much of the code in Rootstock is either yours or have you been involved in creating over the last, 7 or 8 years?
I think that a big portion of what's happening in the bridge, in the POPEG, in the 2FA application, I was actively coding it or actively reviewing it or challenging it. So yeah, most of the bridge, I will say.
Amazing. So we're speaking to the guy that has built the link between Ethereum and Rootstock and built the link between Rootstock and Bitcoin. And on a personal level, you work in the blockchain sector and you work on Rootstock. What motivates you to work on this particular problem? What is it about this that you like?
I think that it made me grow a lot. I have around 20 years of experience, and in here, in the past 6 years or so, I learned that you can never stop learning. The technical challenges that we face on a daily basis in this industry are sometimes overwhelming, but definitely rewarding.
So it's the
technical challenges.
It's the depth of the challenge and how that stretches you and pushes you to learn and be better.
Yeah, and the people that I've been meeting in here for so long, it's like every time you learn from people all the time and you meet new people that it's teaching you more. So that's exciting as well.
And so 2018 was when you joined what back then was Smart Labs. What were the early days of Smart Labs, now Rootstock Labs? What were they like?
Busy days, noisy days. We were, I think that less than 40 people. Every Latin American people, really passionate people. And we were busy all day and several nights, I would say. So yeah, it was an interesting first year, super exciting, and for a couple of months a little bit scary, but definitely rewarding.
So you were working at Smart Labs before Rootstock went live?
Yes, actually I joined maybe a month before it went live. So it was actually before it went live, but I didn't contribute to the early days. So I'm just taking the prize.
Amazing. Stories of a lifetime. Okay, so we're going to talk about RBTC. So maybe in very simple terms, just as a starter, in very simple terms, we're going to get into this in a lot more detail. What is RBTC? So there's going to be a lot more opportunity to expand.
It's BTC. It's BTC running on a separated blockchain, but it's backed by Bitcoin. It's equivalent to Bitcoin. It's completely one-to-one pegged. So it's basically Bitcoin, but with smart capabilities. It allows you to execute smart contracts. And that's as simple as I can go.
And to go one slight technical level deeper, it's an ERC20 token.
It's not exactly the same as an ERC20 token.
Okay, why?
The difference between for instance, the RBTC, probably the most known ERC20 that it's running right now on Ethereum. That one is a custodial token. There is a custody, a safe of the Bitcoins that are running through Ethereum, but they are custodied by a third party. In this case, it's the community themselves that are locking those Bitcoins that are then released on Rootstock. So it's basically the same amount of Bitcoin that exists or will ever exist reside on Rootstock. Whenever a user, a company, whatever, decides to work on using Rootstock, they lock those Bitcoins into the POPEG, and that is released into Rootstock. Once they want to get their Bitcoin back, they do the same process in vice versa, and they recover the Bitcoins on Bitcoin. So it's not an ERC20, it's a token that exists on Rootstock, but it's completely custodied by the bridge itself. It's a smart contract that exists on Rootstock, and it's not custodied by an actual third party.
Okay, so you mentioned wrapped BTC on Ethereum and how RBTC differs from that slightly. For people listening who might be from other ecosystems that perhaps want some analogies to compare it to, what would you compare RBTC to? I've sometimes described it as it's a little bit like a Bitcoin stablecoin, is perhaps one way to think about it if you're perhaps maybe looking at it from maybe an exchange perspective. It is obviously unique and has unique characteristics, and those characteristics, are not comparable. But in terms of mental models, so that people can understand what RBTC is like, how do you think about it? How would you compare it to other tokens?
I think that the only one that I could compare it with is Lightning, because it's the closest to Bitcoin. Any other token, it's walled by a custody, basically a custody that is going to allow you or not to use those Bitcoins into another network. In this case, this is a network that is paired one-to-one with Bitcoin. It's running side by side with Bitcoin. It's backed and secured by Bitcoin. So I cannot truly compare it right now with any other token that is running on an Ethereum compatible network, I would say.
Right. So it's similar to wrapped BTC, but it's uncustodied because it's held in a smart contract, and it is placed in that smart contract by hundreds, thousands of different actors who do that independently. It is not custodied by a single entity. It is held in a smart contract. And so what can you use RBTC for?
Anything that is written on a smart contract, will require gas for it to be executed. RBTC is used to pay for the gas of all the transactions that you want to execute on a smart contract. So basically what you're saying here is that you can use Bitcoin to execute whatever smart contract that resides on Rootstock.
So it's equivalent to ETH on Ethereum. On Rootstock, definitely. You use RBTC to pay gas.
Exactly. It's using Bitcoin to execute smart contracts.
What's interesting, though, is not only can it be used for that purpose, but much like ETH can also be used in Ethereum, is it can be used as a store of value on Rootstock as well. So you can bring RBTC into Rootstock. You can use it to pay for gas, to execute smart contracts, to pay for transactions, but you can also hold it. And because it is a direct one-to-one peg with Bitcoin, it will appreciate or decrease along with Bitcoin at the same time. So then getting a little bit deeper, thinking about the blockchains themselves, what is the relationship between the Bitcoin blockchain and the Rootstock blockchain? And how do those two networks connect?
I think that you actually said it when we started. Rootstock is a sidechain of Bitcoin. In a sense, we could say that it's the first L2 for Bitcoin. It's every time a Bitcoin block is mined, this is informed to Rootstock. So Rootstock has a full understanding of what's happening in Bitcoin. At the same time, every time a Bitcoin block is mined, there is information about what is happening in Rootstock. In another conversation, probably you have heard about the merge mining and the information that is shared between Bitcoin and Rootstock. So these two blockchains, these two networks are linked through the blocks that are mined. Basically, I will say that is the main connection between these two blockchains.
And if we're thinking now about the asset, so that's how the two networks are connected, the economic, cryptographic, and monetary link that Bitcoin and Rootstock have. What's the relationship then between RBTC and BTC, the asset? And at this point, let's maybe get a little bit more into the depths of how the technical relationship works, how the PowPeg works.
Perfect. So I was saying that there is a smart contract on Rootstock called the bridge. This contract has, when it was created, when the Genesis block of Rootstock was created, this contract started having 21 million Bitcoin in the shape of RBTC. In this case, the bridge is custodying all this potential surplus of Bitcoin for it to be transitioned into Rootstock. So how do we extract this RBTC from the bridge? For this to happen, there is a process, there is a protocol called the two-way peg that allows users to convert the BTC into RBTC and the RBTC back into BTC by using the PowPeg. What is the PowPeg? The PowPeg from Bitcoin side is a Bitcoin address that is a multi-signature Bitcoin address. This is a common Bitcoin script that allows multiple signatories to allow a certain operation to exist. Once a user sends BTC to this specific PowPeg address, there is this process called the peg-in that will take this transaction, inform it into the bridge, and once the bridge takes notice of this operation, it's going to release RBTC into a given Rootstock address. This is the way how a user that got BTC locked it into the PowPeg and got RBTC in Rootstock. When the user has this RBTC, they can operate in Rootstock using whatever protocol, whatever smart contract they want to use. And whenever they want to get back into Bitcoin with the remaining of the BTC they have, they need to process the opposite, doing a peg out by sending the RBTC back into the bridge. And when this is confirmed, when this is accepted, the PowPeg is going to sign the peg out operation, basically sending the remaining BTC back into this user.
So where
the relationship then? Yeah.
So where is the RBTC? Is it on Bitcoin or is it on Rootstock?
The RBTC is only on Rootstock.
So then the two-way peg mechanism is a combination of both and we'll get into the PowPeg architecture separately, but it's in simplistic terms, it's a combination of a Bitcoin address and a Rootstock address with a smart contract attached, which interact.
Exactly,
Is there anything weird that happens when the two networks connect to each other and talk? Can you tell me a little bit about how that works?
Sure. So given that we are changing from one network to the other, there is a process that needs to happen. There is information that needs to be shared. There are confirmations that need to transfer. Otherwise, it's not as simple as sending from one Bitcoin address to the other, right? Because we need to connect two worlds in a sense. For this to happen, there are special actors in the blockchain in Rootstock called the pegnatories. These pegnatories are the ones conforming the PowPeg. These actors are the ones responsible to sign the peg out operations that will move RBTC into Bitcoin. To go in the other direction, for a user to be able to send BTC into Rootstock, I was saying that there is a special address. This special address is actually something that the bridge, in a decentralized way, is exposing. The bridge allows any user to know in which Bitcoin address deposit Bitcoin for them to get RBTC into Rootstock. There is no like centralized way of accessing this. It is in the bridge, it is on the blockchain. Once a user sends this Bitcoin into the POPEG address, after a number of confirmations, these are Bitcoin confirmations. After these confirmations, the transaction and the block on Bitcoin will be informed into Rootstock. It can be informed by any user. This is, again, a way of decentralizing the operation, not relying on any single actor, but allowing any participant in the community to inform that a certain user sent an amount of BTC into the POPEG. Once this happens, the bridge internally is going to process the Bitcoin transaction and the information within it to determine where to receive the RBTC, how many and where to receive it. If you want, we can delve into the details on how the bridge determines where to receive the RBTC, but in simplistic words, this is established or extracted by the bridge from within the Bitcoin transaction. Everything is on chain and nothing is actually like imposed by any external actor.
Okay, so let's pause at that point and zoom out a little bit. So let's say I'm a user and I want to get RBTC. There are lots of different ways to do that, from centralized ways to highly decentralized ways.
Yes.
Can you take me through the different ways that you can get RBTC today? And maybe let's start from the most centralized, most expensive ways to get RBTC today. And maybe the fastest. Let's look at them in terms of speed and cost.
Okay, let's talk first about decentralized ways of accessing, right? We have exchanges around in the network. There are many exchanges that allow users to convert any asset to RBTC. The velocity of these exchanges will depend on the exchange themselves. The reliance that you have on those exchanges is, again, depending on their service. If we move away from those extremely centralized exchanges, we have other parties. There are DXs running on Rootstock that allows you to convert from different assets into RBTC and back from RBTC. And then we have tied in with the bridge protocols. The most native one is the 2A peg, that we were describing. That, by the way, there is an application that was some time ago released. That is a DApp that allows you to interact with the bridge in a more simplistic way than the historical way. And there is also a protocol derived from the 2A peg that is called the flyover protocol, which is faster. It's way faster than the regular 2A peg, but it has an additional fee because there is a liquidity provision in the middle. So there are actors that are advancing funds, so we don't have to wait as a user for the bridge to actually process all the transactions. And finally, as in basically any other blockchain, we have the possibility of using peer-to-peer swaps. And in the future, we are seeing more connections coming with other networks, spoiler alert, Lightning, and many more to come. So yeah, I will say that the cheapest way of doing BTC to RBTC conversion is the 2A peg, the native 2A peg. Probably the fastest way of doing this is going to be an exchange or the flyover. And the most decentralized way of doing it, again, it's the 2A peg.
Okay, so you've got centralized exchanges where you can buy RBTC. You've got decentralized exchanges on the network like Oku, an implementation of Uniswap v3, the Sovereign DEX, and there are many others as well. On-ramps and off-ramps. The 2A peg app, more decentralized, the most decentralized, in fact. flyover, slightly less decentralized, but faster and good for small transactions. And then, of course, you could do a simple peer-to-peer swap, so 2 wallets sending RBTC to each other.
Correct.
So how do you convert Bitcoin? You've explained a little bit how you convert Bitcoin into RBTC and how you convert it back using the two-way peg. Maybe let's say then, how do I receive RBTC? And maybe this is a good way for us to talk about the evolution of the recipient address problem, which has changed over time. So maybe how would I receive RBTC as a recipient, and how has that changed over time?
When you do this using something like an exchange, you basically state the address where you want to receive it, right? So that is known and simple. When you do this using the two-way application, you have the same capability. You basically connect your Bitcoin wallet, you establish how much you want to send, and you specify in which Rootstock address you want to receive these funds. It's simple. It's basically the same as an exchange. But this wasn't the case throughout the history. When we first launched Rootstock, the way for the pay-in-to process was, I'm going to use the word basically, but it's nothing but basic. We needed to derive the recipient address from the sender address. There wasn't any kind of data into the Bitcoin transaction that allows us to decide where to send the funds. So the mechanism to do this was using the public key in Bitcoin. For those who don't know, the public key is a way for basically specifying that I own a certain private key, but without exposing private data. And an address basically is like a fancy envelope on top of a public key. So we needed to extract the public key from the Bitcoin transaction to determine who was the sender. And using that public key, we could then create the Rootstock address on Rootstock for the user to access those RBTC. This was not simple for technical users even. So this was a huge challenge that the community expressed, and in Rootstock, the developers.
When was this? When was this challenge first being sort of resisted by the community, or were we getting feedback on it?
In 2018, right
immediately.
Away.
And how long did it take to move away from that to a more simplified model where you can where you're not having to derive the address from the public key?
I don't have the exact date when we activated it, but I think it was in 2019, probably, I would say, where we had to basically use Bitcoin to include certain metadata using something that then for basically BRC20 ordinals, everyone is using this idea of the OP return metadata that you can put into Bitcoin and allows you to put whatever you want to put after certain specific opcode called op return. We use that to include certain information that includes the recipient address on RBTC. And in the future, we may extend this to allows you to I don't know, just to say something, to execute a smart contract. I don't know, in the future, we could extend this protocol to allow you to do additional actions. But in the meantime, what we have right now is that you specify the actual Rootstock address within the Bitcoin transaction. So you have in Bitcoin already the evidence of this user that is sending BTC, it's sending it to Rootstock into a certain address. Once the bridge receives this, it's basically extracting this data and sending the RBTC into the recipient address. So it's way more simpler than the legacy method that we were used to use, which, by the way, is still available. If a user wants to use it, it's still available.
So you mentioned, I'm going to ask a very dumb question, but I think it might be quite an interesting way into some of the discussions around the PowerPeg. So theoretically, so once upon a time there was a locking cap. So this is the amount of Bitcoin that can be bridged into Rootstock for RBTC. And this was basically a facet of our defense in depth approach. It was a kind of a human error check to make sure that as Rootstock grew, It didn't grow to such a radical extent that the amount of Bitcoin coming into Rootstock could somehow increase the propensity for attack, the kind of attractiveness of attacking Rootstock and attacking the two-way bridge at that kind of early two-way peg at that early stage of the company when we were building out Rootstock in the early days. That was removed, I think, about maybe like 18 months ago. And now, theoretically, you can bring 21 million Bitcoin into Rootstock, although, as I was reminded yesterday, that would also include Satoshi moving his Bitcoin as well, which, we hope to happen at some point. But you mentioned that the smart contracts in the PowerPeg has 21 million RBTC essentially ready to be unlocked. Is that accurate? Are there 21 million RBTC ready to be swapped for Bitcoin?
Yeah. As I was saying earlier, the bridge holds all the amount of Bitcoins that could exist. They won't be released into Rootstock unless the same amount of Bitcoin are locked into the PowerPeg. So it's not like we have them, let's use them. It's basically the Bitcoin community has the power to bridge those potential 21 million Bitcoins into Rootstock and use them as they please.
And so let's look at this then. So how do you know where you're going to get your RBTC?
How do you know?
How do you know? How do you know where your RBTC is going to arrive?
If you use the two-way peg app nowadays, where you simply put your RBTC, your Rootstock address, that's how you know it. Once the transaction is performed, once the transaction is informed to Rootstock, then you will get those RBTC into the designated address. If you don't do it in that way and you do it in the legacy way, then basically what you will need to do is to run a heavily technical process where you need to extract your address, your Bitcoin address, extract from that address the public key that shapes this address, and then use a tool to convert this public key into a Rootstock address. This is something that if any listener now wants to use it, this is actually available in the Rootstock dev portal, explaining how to do it, because again, this is still available. I would say that it's not the recommended way because it's actually quite cumbersome. And there is an additional reminder for users here to do. When you use the pay-in to any address, as we call it internally, where you choose the destination address, you can use whatever sender address you want in Bitcoin. Let me put some emphasis here. So if you are using the peg-in to any address, you could send Bitcoins from a SegWit address, from a multisig address, from whatever kind of custom script may exist right now in Bitcoin into the bridge. If you use the legacy method, the bridge needs to understand how to process the script, how to extract the public key. So if a user were to send from any kind of unsupported address into the bridge using the legacy method, that the bridge wouldn't be able to process that transaction. So I would say that it's not only that it's simpler, it's up to a certain point more secure.
Okay, so we've been talking around one of the big questions here. So we've discussed in some detail from different directions what RBTC is, how you access it, and what you can do with it. But we really need to talk about the two-way peg and the pegnatories. So can you start by describing at a high level what the two-way peg is, and again, in simple terms, how it functions, and then we'll go a level deeper and get into the different aspects of it. So what is it and how does it work?
Okay. The two-way peg is a mechanism to convert Bitcoin to RBTC and RBTC to Bitcoin. That is the simplest way of saying it. How do we do it? For us to do this, we need to use the bridge to determine who are going to be the members of a multi-signature on Bitcoin called the PowerPeg. A multi-signature, again, is a Bitcoin script that requires a certain amount of signatures before it can actually be spent. So it doesn't allow any specific actor to decide on where to send the funds or not, it requires half plus one of signatories to be in accordance with the operation. Who are these pegnatories, how we call them, and what is their capability?
Yeah, what are they? Are they people? Are they companies? What is this? Is it a device? Help us understand what these pegnatories are.
Let's start like from the generalistic way, and let's go specific later. So these are companies. These are companies that belong to the community, and these are companies in the community that invest, in a sense, in the trust to build on Rootstock, and they are actually using a device. They are not choosing what to sign. They cannot specifically decide whether a transaction needs to be signed or not. We in Rootstock, we created this concept called the POHSM, that basically it's secured by Rootstock itself, aka by Bitcoin itself, and disallowing any bad actor, any ill actor, to decide on spending funds to something that was not actually processed by the bridge. Okay, so we have the POPEL that is custodying all the funds. There are companies shaping this POPEL. They cannot decide on how to spend these funds. They are simply responding to the stimulus coming from the bridge. The users, RBTC owners, are sending RBTC into the bridge, and the bridge is demanding to the pegnatories that they need to sign a payout transaction. Reminder, a payout transaction is a Bitcoin transaction that is spending funds from the POPEG sending to a user or to multiple users from a consensus change that happened a couple of years ago. We are using this device, this POHSM device, which is secured by the bridge itself, by Rootstock, by Bitcoin. So there is no way for a user, for a hacker, for a pegnatory to decide how to spend these funds if it isn't through the bridge following the known protocols.
So there's a lot of misconceptions around how the Rootstock two-way peg works. Is the two-way peg centralized?
No, not at all. Not at all.
Can you explain why?
Yes, definitely. For a user to peg in, they simply need to fetch the Bitcoin address corresponding to the POPEL, and they do this from the bridge. They shouldn't rely on any other mean. No, it's the bridge. This is a transaction that it doesn't have any costs. You don't need to have RBTC for you to get the bridge, the POPEL address from the bridge. But you shouldn't trust on X. You shouldn't try it on a website. You shouldn't trust on anyone. You shouldn't even be trusting on yourself from previous operations. You need to fetch the POPEL address from the bridge. Once you have it, you send Bitcoins into this POPEL, and you don't need to rely. The community doesn't need to rely on the POPEL, the pegnatories, Rootstock Labs, or whoever member of the community to do this. Anyone in a decentralized way can inform the Bitcoin block headers that include the transaction, and they can inform the Bitcoin transaction into the bridge. And once this is done, this user will have the RBTC on their wallet. So there's no one that is actually needed to perform this operation, but the user sending the Bitcoins into the POPEG address.
So let me ask you this: the POPEG centralized?
No, it's not centralized. It's a multi-signature, so it requires a specific number of signatories, but it's not centralized. This is decided, this is chosen through a mechanism in the bridge. This is stored in the bridge, and these special kind of users run this POPEG, use this POHSM to sign the Bitcoin transactions to spend funds from the POPEG.
And the POHSM, so proof of work hardware security module, they are secured by proof of work.
Correct. Exactly.
Can you explain how that works?
This device, basically, it's a smaller client of Rootstock. It's a device. It's actually many people here may know Ledger. The Ledger devices are hardware wallets. These hardware wallets contain private keys internally that cannot be exposed. This is something quite similar. Right? This is actually a repurposed hardware wallet that their only purpose is to sign Bitcoin transactions that were created by the bridge. How it does it? Basically, this device exposes a couple of methods to let it, the signatory inform, provide the evidence, this proof of work that you were describing, that the bridge truly created the request for creating this Bitcoin transaction. Right. Once this is confirmed, and only then, this PoHSM device will provide a signature for the Bitcoin operation that was created by the bridge.
So it will only respond to requests from the bridge smart contract itself. It wouldn't respond to a request from a human being interacting with it.
No, only for a bridge.
And so this gets to the heart of maybe one of the misunderstandings about how the two-way peg works. It's not possible to physically interact with the hardware security modules as a human being. You cannot steal them. You cannot interact with them. You cannot do anything with them physically that would allow you to, in some way, access the Bitcoins in the two-way peg, because the hardware security modules are only programmed to interact with the POW HSM. Sorry, with the two-way peg smart contract. Correct. They can't do anything else.
You could steal it, but you won't have anything but a brick, right? It doesn't work. If it is not by the bridge, it is not going to respond.
Love it. Thank you. Okay, so who controls the two-way peg, and how can we believe you?
Who controls the two-way peg?
Does anyone control the two-way peg? The community.
The bridge controls the two-way peg.
Right.
The community, it's basically every time there is a consensus change, the consensus changes are the only ones that can truly change the bridge. And how do we make consensus changes? These consensus changes are something that is communicated to the community. They have the time and the opportunity to express if they agree or they don't agree with a certain change in direction.
Through RSK improvement proposals, through community calls, through publishing in advance of the open source code changes that are coming. And that's the mechanism through which you change the potential interaction that the two-way peg has, right?
Exactly. The only way of doing it.
So who controls the two-way peg? Publishers of RSK IPs, the community, and anyone involved in creating in some cases, a hard fork of Rootstock, right?
Exactly. And let me put a pause in there, because why is that? Something that we didn't touch in the conversation for now is that the bridge has a special quality, which is that it's a native contract. It's a contract that resides on the actual consensus. It resides on the nodes. So it's not a smart contract written in Solidity that was deployed at some point. It actually resides on each node. So for the consensus rules, for the business rules of the bridge to change, we need a consensus change. Therefore, we need the community approval.
If you were going to attack the two-way peg, how would you do it? Explain it to me like I'm a criminal mastermind. I am living on an island in the middle of the Pacific. I have somehow come across some nuclear weapons. I've got submarines. I've got, maybe I've got some underground data centers and, and a white cat. How would you attack the two-way peg? I'm interested to know how hard it would be to give people an understanding of the barriers that are in place to stop someone from doing it.
Basically, for you to be able to steal funds, from the two-way peg, from the bridge, you need the same capabilities to be doing the same with Bitcoin. You will need to have the 51%.
You need a 51% attack, right?
Yes, exactly. So that's how hard it is for anyone to attack the bridge.
And maybe
even that we are secure by Bitcoin.
And maybe at which point you would say, well, if you've managed to amass the level of computing power necessary to attack Bitcoin, why would you attack the two-way peg? Maybe go and attack Bitcoin, right? So you've maybe given me. So essentially, it's economically and computationally possible, but almost entirely infeasible and slightly ridiculous to suggest that you would amass that level of computing power to attack the two-way peg.
Definitely.
So it's possible, but you wouldn't do it.
Yeah, exactly.
And so I think The architecture of the two-way peg wasn't always like this. Originally, it was a federated bridge in the very early days back in 2018, but it moved away from that. Can you tell us a little bit about that journey, maybe, and the evolution? I mean, I was talking earlier about how there's this misunderstanding of Bitcoin, that the Bitcoin blockchain is this kind of static network that's never upgraded, that's never changed, that doesn't require anyone to work on it and prove it, which is completely false. There are Bitcoin core developers all over the world working tirelessly to try and address bugs when they arise, or deal with all sorts of different issues, often funded by grants and by organizations that are supporting it. And Rootstock's no different. What's the evolution of the bridge to Bitcoin been like, starting with the federated bridge and then moving away from it? Because I think one of the things that people don't quite understand is it is no longer simply a federated bridge. Can you maybe talk about that journey? That'd be super interesting, because you were involved all the way through it.
Yes, definitely. In the early days of Rootstock, it was a federation, right? It was a multi-sig. It's in the very basic concept, it's still a multi-signature, but there is, as we were saying, there is a hardware device behind this multi-signature that is not a federation. In the early days, it was. Basically, there were keys that certain actors were holding, and they were the only ones that knew those keys, but they were able to do what we were describing earlier. They could decide whether to sign this transaction or that transaction. Therefore, there was a possibility for an ill behavior. Immediately, and probably not immediately, actually, way before this went live, our chief scientist, Sergio Lerner, was completely crazy about this couldn't be done in this way, so we need to find a better way of doing it. So the first iteration of this was removing this idea of a private key somewhere and started using the HSM devices. But it wasn't a POW HSM device. It was just a repurposed hardware wallet that kept these keys hidden from any prying eyes. So we changed from the very basic federated model into a more secure federated model using these HSM devices.
Which is then in turn secured by Bitcoin proof of work.
Then we transition into this POW HSM that is secured by Bitcoin proof of work, and we didn't finish there. We don't only have the security by Bitcoin. We also included this attestation that we have nowadays on the POW peg, but which, by the way, right now we have 8 out of 9 pegnatories with attestation. What is attestation? Attestation is basically a certification, in a sense, provided by the hardware security module manufacturer that we are actually running a certain version of this device, that we are actually running a certain version of the device, that the public keys that we are expressing are in the bridge, came from this device and this device only. So we are demonstrating to the community that we are truly running these devices and that the members cannot decide whether to sign certain transactions or not. So in the middle of this, we had the locking gap that you were describing, because we as we were growing, we said, hey, we need to be truly comfortable with the level of security we are providing to the community. We don't want to make a mistake. I mean, we're humans, we make mistakes. So let's try to find a way to prevent from this. And not only that, Daniel, at some point we said, okay, what happens? Because you said something, what happens if anyone steals all the devices, if there's a huge EMP that destroys all the HSM devices at the same time? So in the Bitcoin script, we have one last layer of security, which is called the ERP, the Emergency Recovery Protocol, which is a second set of signatures that could be used after a year the funds for the POW peg were sent. So if after a year the pegnatories are unable to operate, there is a secondary mechanism that allows the community to recover the funds from that failed POW peg. So I would say that since before the day zero, Rootstock Labs' commitment was with security and with decentralization. We are moving all the time towards improving security, improving decentralization, and as you said, it shouldn't be seen as we are static And the same goes for Bitcoin. We are always looking for that.
So let's talk about that. I mean, within the current architecture of the two-way peg today, there are opportunities because the 9 pegnatories that you mentioned, that's a limit imposed by Bitcoin. But there is a route to which we could get to 66 pegnatories. Is that correct? Can you just explain some of that? Because I know that, and we're going to be very public about this, I think, as we publish our roadmap in the coming weeks and months. But there's a route to get to more pegnatories. Can you just explain what that route is, and feel free to go into as much detail as you like?
Definitely. I was describing that we have this multi-signature. We even included this additional layer, this ERP protocol. These are technical decisions that have a trade-off. With the type of Bitcoin script that we are using right now, we are consuming too many bytes of the amount we have available on Bitcoin, which this allows us to extend the number of pegnatories to more than 9. This is a reality right now. But what is the technical group doing right now? They are working on making a migration from the current script, which is called the P2SH script, into a SegWit script. The SegWit script is basically changes the position where these bytes are stored, allowing us to extend the number of bytes that we can use. This number of bytes translate into pegnatories that we could include. As you were saying, up to 63, I think it was more than 60, which is way more than we have right now. So we have the team working on implementing. It's not an exploration, it's actually an implementation that is actually taking place right now.
So we have the route, we know how to do it, it's just about implementing it at this point.
Definitely. And this is actually also going to make the payout transactions cheaper in the end, because by using SegWit, we are saving the fees that the users pay on the payout operations. Not only that, but also we are looking for alternatives for the PoHSM devices, because having a hardware wallet is not something that is that simple. It implies certain expenses. So we are looking for alternatives to also create some redundancy on the availability for pegnatories to join us.
Now, there are explorations going on at the moment, without going into too much detail, about how an alternative architecture for the bridge with Bitcoin would be constructed. And I think BitVM has been an innovation that's pointed a way towards how you can build a bridge with Bitcoin in a completely different way to the federated model that we originally used, and even the PowerHSM model that we use today. Can you talk maybe a little bit at a high level around what a conceptual design for a BitVM bridge between Rootstock and Bitcoin would look like?
Well, let's go to the future. Let's try to take a look at the future. And if we were taking a look at 2 years, maybe less, in the future, we may be seeing a completely decentralized PoPeg. Even it wouldn't be a PoPeg itself, right? It would be a decentralized number of validators that will verify that a certain Rootstock transaction happened that implies moving Bitcoins on Bitcoin without having to even wait that much for that operation to happen, without having to pay that much for that operation to happen. So that is like the most simplistic and futuristic way of shaping it. I wouldn't like to step on the people that actually knows more about it.
So that would be moving from a model where essentially you have a series of signers signing a transaction to a model where you have validators validating whether a transaction took place or not, or whether a block was mined or not.
Exactly.
Okay, very cool. So to my understanding today, the Rootstock two-way peg, the Rootstock Bitcoin bridge, remains the largest Bitcoin bridge in operation by volume. Is that your understanding as well?
Yes, correct.
So despite the fact that we are relentless in our pursuit at Rootstock Labs to evolve the architecture around the bridge, it still remains today the premium example of how you can bridge Bitcoin out of Bitcoin and put it to work on another network.
Yeah, and as I think we have repeated this many times, our network has never seen any downtime. whatsoever. So that's not an easy fit. And again, we are always looking to improve decentralization and security. It's not just resting on that, you know. So
And
yeah,
that's something that you personally have been involved in, right? You can take some level of credit for making sure Rootstock has stayed up for, I think it's 2,800 days or something like this. 6.5 years, right? 6 years, 3 months.
yeah.
All right, fantastic. We've had a great conversation here. We've talked in depth about something very specific, which is RBTC, what RBTC is, how you move Bitcoin from Bitcoin into Rootstock, what the smart contract at the heart of that transaction looks like. We talked about the two-way peg architecture as it exists today, what a speculative future bridge between Bitcoin and Rootstock would look like. And we also touched on, from a user perspective, how using the Bitcoin Rootstock bridge is a mechanism to bring Bitcoin into Rootstock, but even within Rootstock, there are different mechanisms you can use to get RBTC, from centralized exchanges and decentralized exchanges through to the flyover, peer-to-peer swaps, and on-ramps and off-ramps. So this has been really, really great. And look, I think for something that is absolutely fundamental and at the core of the user experience of Rootstock, it's been great to talk to you, Jose, about everything RBTC and everything PowerPeg. And yeah, look, on behalf of the community, thanks so much for your ongoing contribution to Rootstock. It's it's something that is hugely valuable to the community.
Well, it was a real pleasure for me. I'm really glad to be sharing this with you and with the community. And again, I think we are always looking for feedback. So whatever the community needs to express, anything that you think that it's going to contribute to our expansion, to our implementations, please reach out to us through Discord, through X, through whatever mean, and we will look for it.
Amazing. Thanks so much. All right. Nice one, Jose. Thank you so much. Thanks, everybody, for listening. Thanks for watching along. See you soon.